Good morning. My name is Scott Haywood. I'm the Chief of Staff here at TxDOT. I'm excited to be kicking off day 2 of the Texas Transportation Forum. Yesterday afternoon, we had a really exciting panel about the future that was led by Commissioner Meadows. And this conversation this morning should really build off of some of the themes we heard yesterday as they were talking. A lot of what the conversation about the future was driven by what kind of technology we're going to be looking at. And we have some great panelists this morning that all have pretty disruptive technologies that I think will play a pretty significant part in what that future looks like. You know, Texas needs to develop the capacity to be a thought leader on emerging technologies and what their potential is to enhance the transportation system. So TxDOT is actually in the process of developing a technology task force that will provide an opportunity to look at how we can integrate technology into our transportation solutions. We're really excited about that, and we're actually hoping that some of the panelists that you're going to hear from today will be a part of that, because we want to make sure that we're listening to the thought leaders that are already out there as we move forward. And this morning you're going to hear about how technology is reshaping transportation, not just in Texas, but around the world. I want to make sure at the beginning that we let you know we do expect to have a lot of time for questions from the audience this morning. So as the panelists are talking, please start thinking about what some of those questions are going to be. We have microphones down in front on both sides. And once we get to that point, our moderator will be inviting folks up to ask some questions of the group. So I'd encourage you to take advantage of that. And I also, this would normally be the time when I ask you to silence your cell phones, put them away. And I do want you to silence them, but since this is a technology panel, I would also encourage you to have your cell phones out and be tweeting and using all the interactive tools that we have as part of this conference to take advantage of that opportunity, because we do want to embrace technology as part of this panel discussion. And because we have such a great group up here, I'm gonna get out of the way and introduce Scott Belcher, who's the President and CEO of Intelligent Transportation Society of America. Scott is our co-host for this panel, helped put this panel together. We really appreciate the partnership that we've had with ITSA and look forward to this great discussion. Thanks, Scott.
Thank you, Scott. Well, good morning. I'm thrilled to be here. And I'll tell you a funny anecdote. When I arrived yesterday and got dressed to come down to the reception, I realized I didn't have any ties, and I knew my wife would be really mad at me. But then I realized that I was moderating the technology panel, so that was okay. So I hope I'm not usually this informal, but sometimes I am. So I'm the president of the Intelligent Transportation Society of America, and many of the organizations who are represented here are members of ITS America. We're the nation's chief advocate for the use of technology to solve transportation problems. And so in a time where we've got constrained resources, in a time where the world is changing as just incredibly quickly, technology plays a big role. And it plays a big role even in as arcane an arena as transportation. Our members are public agencies. We're pleased to call Texas DOT a member and a leader within ITS America, Capital Metro, via the Houston Transtar. So plenty of public agencies, state DOTs, city DOTs, MPOs, and universities. University of Texas, Texas Transportation Institute are all members. On the private side, we've got everybody from the automobile manufacturers to the infrastructure providers, and everything in between, IT companies, Verizon's, the telecommunications, because it's all about data now. So one kind of shameless plug. This is an amazing meeting to have 1,400 people here. Congratulations. I mean, it's really key. If you think that this panel is interesting and you're really interested about how your organization should be deploying technology and what's out there, come to the ITS America annual meeting in April. We'll be actually showing the technology. We'll have conversations like this throughout the course of the couple of days, and we'll have thought leaders there as well. So I'm really fired up about this panel. I mean, we've got, I think Scott mentioned it, I think the key word is disruptive. And when you think about who we've got here, we've got folks from organizations that are doing things differently. Transportation tends to be an incremental process. We tend to change slowly. We tend to make little steps. Well, these are companies that have, the companies that we're going to talk to and the issues we're going to talk about are, how do you not make incremental steps? How do you leapfrog technology? And those are the kinds of folks that we've got. We're going to forego the talking heads. So everybody's going to get 2 or 3 minutes to show you a little video and tell you how cool they are. And then we're going to go really to focus on dialogue. And we hope you'll be part of it, because that's really key. And we're going to talk about some of the really important issues that we face as we try to leapfrog technology and to do really interesting things. So the first person who's going to come up is Wes Smith, who's the CEO of a company called WAVE, which is Wireless Advanced Vehicle Electrification, or it's an inductive charging technology. So inductive charging is basically using magnets to charge vehicles instead of plugging them in. And what WAVE does is it provides inductive charging for transit vehicles, which essentially allows you to get rid of 14,000 pounds of batteries. 14,000 pounds. Imagine how much more efficient you can be. Imagine what that does for climate change. Imagine what it does for operations. It's a really an interesting technology. Wes has been engaged in commercializing emerging technologies his entire career, both with startups as well as with Fortune 100 companies. So he has a really unique perspective on what we're going to talk about today. Wes?
Thanks, Scott. I want to thank Anthony for having a really cool presentation today and attracting all of you out of your beds to come to this panel. And we're just going to kind of ride his coattails. I do have a video that I want to show you all that kind of describes how the induction works. But just quickly, this illustration, on the right-hand side, you see a plugged-in world. On the left-hand side, you see a wireless world. I'd like you to use your imagination as you see this video of think about what the cellular technology did for landline telephones, and imagine what wireless power could do for vehicles. With that, let's run the video. AV guys.
The WAVE wireless power technology is simple and revolutionary. Like any battery-powered vehicle, the bus receives a full battery charge each night when not in use. Throughout the day, the batteries are drained as the bus drives its route. However, when the bus stops to pick up passengers, it is recharged wirelessly with no cables or overhead wires. This is done through a pad mounted in the roadway and another pad mounted on the bottom of the bus. The roadway pad creates an oscillating magnetic field. Through a process called induction, the bus pad absorbs the electromagnetic energy through the air and transmits the electricity to the bus's batteries, which in turn powers the electric motor. This charging happens every time the bus stops by the charging station, helping the battery last throughout the entire day.
This is the first time that electric power has been economically viable. It hasn't been up to this point because the weight of the vehicles makes it so the electrical costs are not competitive with diesel. But with this, the fact that we're able to use fewer batteries, get a lighter vehicle, means that it's economically viable.
This just represents the next step in electrical powered vehicles. What attracted us to this technology is a way for us to power on the go and to have smaller batteries that power more frequently but allow us to get in and out of traffic and keep running throughout the day without a constant need for repowering.
Once you solve the battery problem, electric buses are far superior to their diesel and natural gas counterparts.
There is no pollution, it's absolutely clean, and wireless power buses can continuously operate without any external input control, and the bus can just automatically charge and never need to stop.
Could you put the slides back up? Or do I need to do that? There we go. So essentially, it's probably good to think of this in the terms of, throughout history, vehicles or mobile devices, if you will, everything from horses to automobiles, have always carried around their energy storage. So what would it look like if you didn't have to carry around your energy storage? It hasn't been a problem when we've been using liquid hydrocarbons because, as this chart shows, petroleum is probably one of the densest power sources in the world. And so you can power a diesel a 40-foot transit bus with about 230 pounds of diesel fuel. It takes comparable lithium iron phosphate battery, about 14,000 pounds, so, which represents about half of the curb weight of the vehicle. So obviously there's a physics problem that you run up against if you're going to electrify vehicles and you have to rely on batteries and plug them in overnight. This model essentially says, let's not worry about power and let's not worry about carrying that power with us in the vehicle throughout the course of its day. If we can chirp that energy into the vehicle during its operations, either stationary when buses load and offload passengers, or ultimately in motion as the bus drives down the road, you've really solved that problem of carrying a lot of that energy storage with you, and you solved the battery problem, which is really the Achilles heel of vehicle electrification. I'm gonna move on. Actually, let me just show you this. Essentially, the model is, let's replace power electronics with battery. Batteries are essentially the same as they've always been for the last 30 or 40 years. There have been some improvements, but they haven't been dramatic. And because of that, we still have this serious limitation. If we can use power electronics, the reason I have this picture on the left is it's probably better to illustrate. This is a Nexus 10. It has far more processing power than this computer on the left. And I picked that picture mainly because it has a steering wheel. And I don't know if anybody can answer the question, why does it have a steering wheel? What is that for? Is it like one of those things in the grocery stores where the kids are, pretending like they're... But needless to say, this Nexus 10 is probably 100,000 times more powerful in its processing power than that machine. We benefit from a lot of the advances that have been made in power electronics, in software, and fast switching technology, which is essentially why now we can transfer power, very large quantities of power, 50 kilowatts to up to 200 kilowatts over a 10-inch air gap, which makes this technology now applicable for vehicles. So I'm just going to shoot to the last slide here in the interest of time. This technology is here now. It's not just in the lab anymore. These are several prototypes. Ours is on the far right-hand corner. That's the what we call the Aggie bus. It's a 25 kilowatt system. It's operating in Logan, Utah right now. The one on the upper left-hand corner is an in-motion prototype that's being operated by Bombardier in Germany. The one on the lower left-hand corner is an in-motion system operating in a public park in Seoul, Korea. And the one on the lower right-hand corner is one of 40 buses that have been operating in Turin and Genoa, Italy for the last 8 years, built and operated by a company out of France called Conductix Waffler. So with that, I think I'm going to hand back over the time to you, Scott. But there's one other thought I forgot about. That's okay. Thank you.
Great. Well, thank you, Wes. And in the interest of trying to be informal, I'm just going to stay here and introduce our next panelist. Next, we've got Brian Heath, who's the president and CEO of Intelligent Imaging Systems, as well as Drivewyze. So Drivewyze is a pre-clearance credentialing program for commercial vehicles. So what that means is that trucks, can go by a a weigh station or a check station and be pre-cleared by the use of by the use of a cell phone as opposed to using transponders or hardware. And so Brian's been involved in deploying integrated roadside technologies and automated vehicle identification in over 33 states and 5 provinces. Brian?
Thanks, Scott, and thanks to the folks here at TxDOT for inviting us, and we hope to give you an engaging conversation. We at Drivewyze are here to share what we're working to do to revolutionize the delivery of transportation services. And most people hear that and don't know what I'm talking about. So we've got a video that gives you a little bit of details, and then I'll ask the folks in the back to start the video off for me.
Drivewyze has interesting potential both as a technology and as a company. Drivewyze can be deployed very quickly. We don't have roadside infrastructure, we don't have equipment, we don't have maintenance contracts, and it's offered free to participating toll agencies. So we're a thin experience for the agency and also a very thin and quick enabling experience for our customers as well.
The Drivewyze services today use mobile technologies such as smartphones, tablets, or any other in-cab technology that provides location-based services and wireless communications. Using a concept called geofencing, the devices can use predefined areas of interest as triggers and do things like request a bypass for a weigh station or to automatically collect and pay a toll for a given tollway.
So one thing that drives every driver crazy is congestion. So whether you're in line to go through a toll booth or whether you're in line to be inspected, sitting in line is no fun at all.
Drivewyze is a very easy way for customers to pay their toll using their smartphone, sign up online. It reduces a lot of the agency cost and customer service center calls. With Drivewyze, they have alternative ways for people who don't have a transponder to pay their toll.
Drivewyze has launched its first product, Pre-Clear, in the summer of 2012. And Pre-Clear is our solution to provide weigh station bypass services using wireless communications and devices. Drivewyze is currently looking at bringing a new service to the market based on similar technology we use for Pre-Clear to enable mobile toll payment collection.
The key advantage that Drivewyze toll solution has over existing transponder-based toll solutions is that you don't have to worry about having multiple transponders in multiple cars. You don't have to worry about having multiple transponders in multiple states.
Because we are doing away completely with the requirement for a transponder, we can actually provide interoperability across multiple services, meaning you can have one single account for both weigh station bypass and toll.
The toll agencies have to be interoperable by 2016. Drivewyze allows that in that combining your license plate and a GPS connected device, you can become interoperable across the United States with any participating agency. So Drivewyze is a new generation of technology that's changing the face of safety and driver convenience on today's highways.
We're looking to continuously innovate and look for solutions to solve some of the common problems we have on today's roadways.
Every once in a while, a disruptive technology comes along that really transforms the way an industry does business. And I think Drivewyze is providing those kinds of solutions to the transportation industry.
So we at Drivewyze are working pretty hard to solve two big pain points in the transportation system. The first, from an agency's point of view, is how do you keep your highways safe and how do you protect your infrastructure without clogging up the flow of commerce. And the second is, how do you make toll payment convenient for drivers who are not already registered to use your service? Thanks.
Great. Well, thank you, Brian. Our next speaker, many of you met over the last day or so, or at least saw the car that he brought, and that's Anthony Levandowski, who's a product manager for Google's self-driving car technology. Anthony spent his career developing mapping and surveying technology, as well as interesting robots like the Ghost Rider, which is an unmanned motorcycle that's at the Smithsonian. How cool is that? I mean, anyways, Anthony, why don't you tell us a little bit about Google's self-driving cars?
Thanks, Scott, for not wearing a tie. I actually don't own one, so that way we can feel more connected together here. I wanted to also thank TechStot for having us here today. We're really excited about engaging with all the stakeholders in the room here and beyond with this technology coming forward. So with that, give me a second, cue it up here. How's that looking? We're good? All right. So first off, we want to start off like self-driving cars is not a new idea. Just like racing was invented when the second vehicle was built, self-driving cars have been around for a long time. In the 50s, power companies of America ran this ad, which I thought was really appropriate for today. It's a power company that's advertising wireless charging, and the fact that the cars are driving themselves is completely besides the point, because this has been kind of technology that people have been dreaming up for a long time, but only now has the technological barriers of computing, infrastructure, data services have been merging to make that a reality. So it's two birds with one stone on that one. One of the things that we see is that we think that technology can make a big difference in the number of lives that are saved every year through technology. And we see this because there's been 32,788 people that died in 2011. And when we look at that, 90% of it or 95% of it was caused by human errors. And for us, it's really all about safety. If we can build technology that can drive better than people can, that means there's a variety of accidents that we can avoid in the real world. And distracted driving, so even just people just not from being going too fast or under the influence, just distracted driving in 2010 caused over 3,000 fatalities in the U.S., which we think is a tremendous number. A lot of people ask, why is Google doing this? Well, we're really a technology company that loves to solve hard problems. And whenever there's an overlap of a solution to have an impact on humanity and a technical challenging problem, that's where Google really plays the best. And our perspective is we want to understand what would the car be like today if the computer had been invented before Mr. Benz invented his vehicle in 1885. And that would be a fundamentally different experience today. Kind of a couple of approaches we've had is, one is we don't want to have any new infrastructure. So we'd love for every tax dollar that's out there to be built for improving the roads, filling the potholes, restriping. These are fantastic use of tax dollars. There's been projects in the past, like California Path here, that have built fantastic technology demonstrators that require new embedded magnets to be built in the ground. And one of our approaches, we said, no new infrastructure. It has to work with the roads that are today, however good or however bad they are. The second aspect is it must work on its own. So there's a lot of people working on, like, well, what happens if you have a professional driver? Could you have your car dock with it? Could it be wirelessly linked? We don't think that this chicken and egg issue of, like, who's going to buy the car that has this before there's licensed drivers that can do it, who's going to become a licensed driver before they can actually get a car that can follow them. So those are two approaches that we said no to. I invite you to come look at the car down there and ask us questions. It's in the lobby of the hotel. It's very simple, essentially. It has a laser. It's a spinning thing on top. It measures 3D around the car. It has a bunch of cameras that look for traffic light, for pedestrians, turn signals. It has a radar that measures the speed. And it's got 4 wheels, so unfortunately it's not a flying car, so that'll be for the next version. Most people know Google as a search engine company that says, don't be evil as its motto. But we also have another motto, which is, in God we trust, and all others bring data. So we love data and we love collecting data. And so I want to share with you a little bit here a couple of the recent developments that we've been seeing in terms of how well does a car compare to driving safely like a person or safer than a person. So one of the metrics we use is time to collision, which is basically how much time do you have if you're driving the same speed as the vehicle in front of you before there might be a collision. And if you plot that, it looks like, you know, the curves are basically the same. It's a cumulative distribution function, basically showing the amount of time that you spend however close to somebody in front of you. But what happens if you zoom in on the part where it's dangerous, basically where you're less than 4 seconds from a collision in front of you, you start seeing the amount of time being the blue line lower there being driven by the machine versus the red line being driven by professional drivers, that in the really dangerous zones, like 2 seconds or less, we're spending 5 times less of our total driving time in this regime, which basically means that we're 5 times less likely to get in these types of accidents there. Well, you might say, like, how does the car drive? Is it really jerky? Well, if you do the same kind of plot and you kind of measure the acceleration of the car, so how smooth is it driving longitudinally, which is a good metric for fuel efficiency in the long term, we can actually see that our gap is narrower about the 0 G, basically meaning we're cruising or coasting more of the time. So with that, our mission is to improve people's lives by transforming mobility. And I'll give you a little video here to inspire you guys. See if this works.
Good morning, Steve. Hey, Nathaniel, how are you? Doing just great. Go ahead, Steve.
Auto driving.
Here we go. Away we go. Look, Ma, no hands. No hands anywhere. No hands, no feet. No hands, no feet. No nothing. I love it. So we're here at the stop sign. Yep. Car's using radars and laser to check and make sure there's nothing coming either way. I find myself looking. Old habits die hard, man. Hey, they don't die. Hey, anybody up for a taco? Yeah. What do you want to do today, Steve? I'm all for Taco Bell myself. All right, well, let's go get a taco at the drive-thru. And we're turning into the parking lot. Yep. How neat. There we go. Now we can kind of creep along here. Does anybody have any money? I've got money. No, I've got my wallet right here. You roll down your window and order a burrito. Yeah, push that. I'm doing very well. How are you today? This is some of the best driving I've ever done.
95% of my vision is gone. I'm well past legally blind. You lose your timing in life, everything takes you much longer. There are some places that you cannot go, there are some things that you really cannot do. Where this would change my life is to give me the independence and the flexibility to go the places I both want to go and need to go when I need to do those things.
So with that, thank you. So other than helping Steve get a taco, we think that it's really important to consider the uses of technology, not just to improve everybody in their rooms, commute to work, make our lives better. That's really important. But it's also important to see how does our technology touch those of us that aren't as fortunate as we are. Because as we get older, everybody's bodies will age, and we will all at some point, I imagine, depend on some technology like this to be able to stay in our homes longer, see our families more often, and live happier lives. So thank you very much.
Thank you, Anthony. So finally, we have Dr. Mike Walton, who's a professor of engineering at the University of Texas, who holds the Ernest H. Cockrell Centennial Chair in Engineering. Mike spent his entire career researching intelligent transportation systems engineering, planning, operations, and policy. Mike's chaired just about every transportation trade association I can think of, including ITSA America. Most importantly for this audience, Mike is a member of the Texas Road Hand Hall of Honor. Mike is here to kind of keep us honest. He's really one of the country's transportation deans, and he's got a perspective that can really help us view these different opportunities that we've got. Mike?
Scott, thank you very much. Of course, it's a pleasure to be home in Austin. And don't talk too much about other activities, if you would. I mean, we have problems with our board of regents and so forth about faculty running off and doing various things. So just let's let that ride. You know, what's exciting, I think, is that this is such a wonderful time to be in the transportation business. It's rich with opportunities, and the students that we see today are excited about the opportunities because it's all changing. It's a multidisciplinary career. We've all known that, of course, but now it really is, and we're bringing new players and new ideas into the program. Watching the film that Andrew just showed, and I'm sure seeing that platoon of GM vehicles running together, the first National Automated Highway experiment was in San Diego 15 years ago, and ITSA America played a major role in that. So did Texas. Houston Metro was there in a big way with their buses, again driverless, operating on I-5. And what reminded me of that was the waving out of the window. Some of you may remember the former chair of the House Science Committee was from California, George Wilson. We put him in the back of one of those platoon vehicles, and we were traveling at about 60 to 70 miles per hour with a headway of less than 2 feet. Scared the hell out of him. I mean, so we then decided that, wait a minute, we have the capability of doing that, but let's spread it out a little bit further so that if we do put elected officials in the back of the car, they can relax and observe what was going on. And indeed, that worked out very well. We also did have a driver, as Andrew knows, from the Army Transportation Corps. They were there to make sure nobody touched anything, you know, or if, on the other hand, if something did go wrong, which nothing ever did, then they could take over. So that driver had the window down, waving at the cars in the non-express lanes, in traffic, backed up in the morning. Of course, that was quite a scene to watch that episode, but it was a great experiment. We have the capability of doing enormous things, but are they yet efficient or effective from a business perspective? Answer is not quite yet in many cases, but yes in other cases. So you've seen a slow adoption of technology, and there's a great deal of capability. If you opened the trunk of those cars 15 years ago, it was full of electronic gear, and the redundancy, even the redundancy that they have in their vehicle, is necessary to give the assurance. So, you know, when you think about emerging technology, and I've got a couple of things here I'd like to show, but if you look at that, you know, there are unexpected consequences of technology every time it's introduced. There are things that we cannot anticipate that occur. Some of them are not good. Some of them are terrific, and we take care of that. But there are some institutional barriers as we think about technology, and I just want to put these out so that we can talk about them later. You know, different sectors of our economy react differently to technology when it's introduced. You know, having spent some time in Toyota City, which is right outside Nagoya, which is the corporate headquarters for Toyota, they have, of course, a lot of work going on in experimental technologies as well. They have a lot of things that they like to show and like to do, but you know, there's a lot of competition in the marketplace. Every manufacturer now has technology that they would love to showcase, but there are necessarily barriers, either institutional, legal, or otherwise, that hinder the adoption and the movement of technology. Government regulation or lack thereof is an issue. You know, even Google has to go around to all the states and get some permission to operate in some of the roadways and so forth. There's the consumers are not really sure how to embrace technology. You know, we've had as options technology available on vehicles for a long time. You could buy it. So we were trying to push the technology into the marketplace, and now we're beginning to see a pull. Just think about the adoption of all the in-vehicle navigation systems that we have and all the other technologies that more or less standard in some of the upper-end cars, but again, options available. There are the barriers, a number of barriers, and I won't go through those now, but I think all those barriers can be overcome. I really do believe that. When we started adopting zero fatalities as a target and as a goal, no one really believed that as a possibility. You're telling me that we can have zero fatalities on our highway system? And of course, a lot of international countries have already adopted that. Several states have adopted it in the U.S., and we keep pushing for that opportunity here as well. And I think that we're making some progress. I'd like to advance this thing real quickly and go through these. I was fascinated yesterday looking at the information that the futurist was talking to us about forecast. If you can see this, and I'm not sure you can from where you are, but population, we do a really good job of forecasting population. We can nail that. I mean, not only do we nail it, but we have 4 forecasts, and one of those 4 is bound to work, but they're all very close together. But then when we start talking about the adoption of technology, and just look at the telephones, wired versus wireless, we don't have, if we don't have an early pattern at the beginning, it's difficult to know what the acceptance rate will be. And you can see that on the wired, yeah, it'd been around a long time. We knew how to forecast that, but the wireless was another issue. And not to go through each and every one of these, but you know, Starbucks, we didn't have, back in '94, we didn't have a very good idea about how Starbucks would be perceived, but we did about McDonald's, and we nailed that. So what about the Internet of Things? You know, if we could take a poll here, I would imagine that most everyone in this room has more than 2, probably 4 connected devices. You're connected. You know, and every corporation in the U.S. and perhaps in the world has a program that's an overhead program. In other words, it's costing them to have either a program in smart cities, connected cities, connected vehicles, on and on. And they have a name for it, and it's not a profit-making activity of the corporation at this time, but they know it's the future. But just look at the growth that we expect in the connection of things. Now, what's in the future? I hope you can see these, and I'll not go through each and every one of them. But the only point of introducing this slide with these bullets is to suggest to you that's a wave coming forward. There's a wave of advances. And if you look at each and every one of those and think, okay, how does this impact mobility? How does this impact transportation? It's enormous impact, potential impact. These are just a few random samples of technology that's advancing. So I think where we are now is the future is in our hands, quite frankly, and it's up to us to make it happen. We don't sit back and wait, and that's why I'm excited about TxDOT's position on embracing advanced technology, at least be at the forefront of thinking about how it may impact the future. And so consequently, it is up to us to create the future with the technology that's emerging. And then, of course, as a Nobel laureate once said, and it was gentlemen because there were no ladies at the ceremony, we have run out of money. It's time to start thinking. So I look forward to the discussion. Thank you very much.
Well, thank you, Mike. I think it's clear that if we stopped right now, this would have been a great panel. The good news is we've got a little bit more time to really have some interesting conversation. So each of these companies are developing and deploying, and I think deploying is the important word, cutting-edge technology that's changing transportation as we know it today. So what I'd like to do is to start the conversation out about kind of what's really driven your organization to deploy these types of disruptive technologies. So Anthony, let's start with you. I mean, Google's self-driving cars have been all over the media for the past 3 years. You've got over 500,000 miles under your belt. But I don't think of Google as a transportation company. I think of General Motors as a transportation company. I think of Toyota. I think of Parsons Brinkerhoff. So what's driven Google, really a technology company, to take this on?
Well, I think we have no intentions on making cars, so that's number one. But I think we really see an opportunity for where software can improve the experience and safety in all the vehicles today. We really don't see the full potential has been used of using all the computing technology that's available today to improve the driving, the experience. And so in terms of commercializing it, we don't understand the path of where we're at yet. We're really thinking longer term. But we really want to test it and make sure that the technology is proven before it gets rolled out.
So I won't be buying a Google car at my dealer anytime soon?
Not anytime soon, no.
Okay. So Wes, why don't we talk a little bit about the transit industry, because that's a very different industry, a pretty traditional industry that's been slow to change, slow to adopt new technology. What drivers do you see that are out there that's going to push the transit industry to adopt electrification?
I think there are two drivers. One is environmental, the other is financial. In a lot of regions, we're working a lot in California, for instance. A lot of those regions are in non-compliant zones designated by the EPA, so they're driven to go to low emissions or zero emissions vehicles, and there really aren't many options right now, fuel cell being the only really viable, but not financially viable, zero emission solution. On the financial side, what was most surprising about this technology when we started looking to commercialize it several years ago is that if you can, in all other respects, electric vehicles are far superior to their internal combustion engine competitors, with the exception of the batteries. The batteries are heavy, they're very expensive, and in fact, I brought up this little show and tell. If you fill these 2 cups with diesel, you can power a bus for a mile. It takes about 106 pounds of lithium iron phosphate battery to power that same bus for a mile, and that battery's about this big and about this high. So you can imagine if your typical transit bus does 130 miles in a day, you have 130 of those on the bus, you have no room for passengers, let alone the fact that it's already exceeded its gross vehicle weight. So it's a problem. But if you can eliminate that problem, many other things start to happen. For instance, electricity, if you power a bus using electricity, the gallon gas equivalent's about 65 cents a gallon. So the delta between that and $3 for diesel or $3.50 for diesel, you can make up your investment fairly quickly. So the most interesting thing I find about the technology is actually not the technology itself, but how affordable it can be once you start factoring in how much you're spending for diesel or natural gas or gasoline.
Great. Brian, let's talk about Drivewyze for a second. So we have a lot of infrastructure out there for technology. We've got Texas has been a leader in deploying electronic tolling. You've got companies out there deploying cameras and sensors and loop detectors. I mean, the states and local governments have been investing in technology and have been trying to move along. A lot of the companies that are here today deploy technology. So does the mobile technology that you're talking about, does it threaten or does it support the current deployment of traditional roadside technology and infrastructure?
Yeah, that's a good question. I suppose it may depend on who you ask. We don't use poles. We don't run power or communication lines to the roadside. We don't hang readers, and we don't use traditional transponders. So if you're a hardware manufacturer, you might think that we're a threat. But the truth is that our goal is to extend transportation services to where they're not currently being delivered. So in the transponder world or toll payments world, there's 20% of toll road users that aren't registered, that don't have transponders. And in the trucking world, there's almost 80% of trucks do not participate in weigh station or inspection bypass services. And so there's a big gap. And that gap can be filled by these mobile technology-enabled services. And what I find interesting is not just the areas where we can deploy these services without any infrastructure, but it's where they can actually be deployed leveraging existing infrastructure. And you can add value to those services by leveraging investments in things like weighing systems, weighing motion systems, or license plate reader systems at toll roads. And you can really leverage the investments that have already been made to deliver augmented services to a larger part of the market, to make it more convenient.
So you don't really see yourselves taking over the world quite yet. You see yourselves as a partner to the existing world.
Yeah, we're all holding hands.
Okay, good. Well, that makes a lot of people much more comfortable. So Mike, give us a little perspective. You've been around, engaged in the ITS world for the last 25 years, back when it was IVHS, back when the private sector thought there was a big pot of gold at the end of the rainbow, and the public sector thought that this technology stuff was going to solve all of its problems. None of that happened. Are we at a different time now, or are things different now?
Yeah, I think so. In fact, what has happened is that we have a generation now of at least one generation that's very comfortable with technology. In fact, they're embracing it. They're driving the other sectors. So consequently, there are still issues like personal privacy, but we all know that that's interesting. That's a two-edged sword. But let me give one example of a case where I think technology and privacy issues are merging. Let's say that you're on late at night and you're traveling on a lonely road, and of course you know everything about OnStar and emergency response systems and so forth. So when you have an accident in your car and you happen to have one of those systems on board, there's a notification that goes out to the closest first responder. But what if that first responder, and we know that time is very critical, as they're advancing to the crash site, they pull up the medical records of the people who they anticipate being in the vehicle. Now you can say, well, they don't really know everybody that's going to be in it. They know who the vehicle belongs to. They could know the medical histories of some of the people. And so consequently, they know before they arrive what to look for. And so we're saving an enormous amount of time at the crash site, knowing what some of the medical features might be. Now, do you want them to have access to that information? I do. I'd love for them to have access to that. I don't care about any of that particular issue. I want them to be able to know what a miserable condition I'm in to start with, so that they know what to find when they get there. So I think that's a case where, yeah, well, okay, that kind of privacy's okay, but it's the other privacy where these guys, when you fire up and they say they want to know where you're located, and you say no, We don't want to do that. Well, they still may know, and still probably do know. and I'm not sure that's all bad, at least for me. But anyway, these are some of the issues that I think that were before us. But because of the embracement of technology by the future generations, we're way ahead of the curve. It's just the few of us that are still lingering, holding back.
Right. I think once we all die off, we'll all be better off, right?
Yeah.
I mean, I know my kids. They would rather be on their phone. They tweet when they go to the bathroom. It's ridiculous. But it's a world where they don't have an expectation of privacy any longer.
They can tweet with the device in their pocket without looking at it. I mean, they know the keyboard. It's amazing.
Well, that's a good segue. Why don't we talk a little bit about obstacles to deployment, because that's really the challenge that we face. I know as within ITS America, one of the questions or one of the challenges we get, especially from the progressive DOTs, is how do we adopt this technology that we've got? I mean, heck, we've got to fill our potholes. We've got to keep the system operating, but we know we need to be adopting technology, but there's always a problem. There's always something preventing us from really doing it in the ways we want to. So, Wes, in the transit world, I mean, what do you think are the biggest obstacles to first moving to greater deployment of mass transit, and then specifically to moving to adoption of electric and inductive charging buses? I mean, because we've got an infrastructure in place, we've got a system in place. How do we make that transition? And what's keeping us from doing that?
Our biggest impediment is the procurement process within the transit industries right now. It's a fairly arduous process, and because the federal government's involved with it, it creates lead times that are much slower than actually we can adopt our technology. We are doubling. We're now following the increasing performance curves of power electronics. So we're essentially doubling our power every 6 months. So we'll have a 50 kilowatt system operating in September through the Utah Transit Authority. We'll have a 100 kilowatt system operating first quarter next year, and then a 200 kilowatt system operating the end of next year. The transit agencies obviously won't be adopting those systems, at least on a large scale, as fast. But we have found our single biggest cost, and it was a point that Anthony made, is about infrastructure. We have a surprisingly small amount of infrastructure that we need. For a typical urban transit route, we only have to trench 3.5 feet by 3.5 feet on one location. And with that single charging unit at the end of the route during the recovery time, we can charge that vehicle throughout the day. As we move forward to more advanced systems that would require in motion, then you're talking about some serious civil engineering requirements on either transit routes or on freeways. The ultimate kind of the nirvana view of wireless power is that all of your vehicles would be electric, and you'd be powering them as you drove down the freeway, and possibly using that same powering system to also assist in controlling the vehicle. But since we're a startup company and we only eat what we kill, we're focusing on stationary transit and what we call off-road industrial, which would be yard goats, yard haulers, things at port facilities and industrial yards.
So, Wes, I'm not very smart, and I'm not an engineer. So when you talk about making the system go from 50 kilowatts to 100 kilowatts to 200 kilowatts, what does that mean?
It's essentially increasing the power level. So our current system that'll be on the road in September in a fully commercially deployable system, for every minute that the bus charges over that pad, it can drive about a half a mile. The 100 kilowatt system, for every minute it charges, it'll be able to drive about a mile. So roughly speaking, it's just increasing the power level so you can increase the flexibility of the system. Your ultimate model is you have a very small battery pack. You charge opportunistically whenever you're stopping to load and offload passengers, in the case of transit vehicles, or transit buses rather, and then you're moving on to the next stop and then charging at that stop for anywhere from 30 seconds to 3 or 4 minutes, depending on how long you're at the stop.
So, Anthony, what about autonomous vehicles? I mean, when do you think we're going to actually see autonomous vehicles, and what do you think the biggest impediments to getting them on our roads actually are?
Well, I think we've stated publicly that we expect these to come out in less than 5 years. But the discussion about what's blocking the deployment is actually much more interesting. And from our point of view, it's really about the reliability of the system and understanding how much can you trust it, how do you verify it, and how do you build all the test cases and figure out all the corner cases or the issues of, well, what happens if, fill in your favorite scenario, making sure that all those rare events have been taken care of. We've been driving the car for many miles, but those miles aren't necessarily representative of everything that's going to be available on the road. So it's also important for us to understand that the technology is not going to solve all accidents. There will continue to be accidents, and so the expectation here is really just to say, we have a tremendous amount of injury reduction potential, but the really hurdle for us is going to be how do we prove and understand and back up with statistics and data the reliability and safety of the system.
So the interesting thing about your answer that I'm not sure I agree with, or that I'm intrigued by, is that you didn't mention state or federal regulators in your answer. You don't see state or federal regulation as an impediment to deployment?
We don't. I mean, I think that there's a good amount of time from when the technology is going to be ready to when it's going to be deployed, or from now until when the technology is ready. And the point of being here today is kind of socializing it and having an open dialogue about the technology is coming, what are people worried about. But ultimately, I think that I don't see any regulators that would be against a car that's safer than what's currently being driven on the road today. And the holdback really is about understanding what does it mean to be safer, and what does it mean to actually achieve that level. So it's more about how do we showcase the technology, how do we actually build the right requirements in there, and not so much changing. I mean, we do think that it would be great to have the existing transportation code clearly address this technology, because when it was being written in the 50s or whenever, it wasn't thought that this technology would be near, and so they didn't anticipate vehicles driving with nobody in them. So the language, to the extent goes, for a person to drive a vehicle, they must be licensed, as opposed to for a vehicle to operate, they must have a licensed operator inside them. But we're working with ITSA and the federal government and the Department of Transportation in each state to try to bring them in and understand the technology and address the concerns they have.
Well, when you work more with the DOT, you'll figure out that it takes a little bit longer. Anyways, that's really interesting. Brian, I want to ask you kind of a bigger question, and because you're talking about using mobile technology, using GPS technology for, right now for tolling and bypass lanes and way stations. But what do you think the real impediments to using it for those things, but also for issues like mileage-based user fees, which are kind of where this country's got to address how it pays, how we fund our system. And so I'm curious what you see the big impediments for using mobile technology for all of these things that have typically been traditional ways that we've managed our transportation system.
That's interesting. I think technology, luckily, is policy neutral. So the impediments on the technical side, I think, are very few. Technology's advancing rapidly. I think just recently there's announcements of new GPS chipsets. They're going to be finding themselves into smartphones that are much more accurate than even the systems we use now. That's going to open the door to delivering transportation services beyond how we're delivering them right now, which is a moving vehicle, which can handle the inaccuracies of current mobile phones. But if you're talking about applications like parking or transit payment systems, and you've got high accuracy mobile devices, it's amazing what you can start delivering in an infrastructure-free way. So I think that technology is not the impediment when it comes to solutions like a mileage-based use tax. I think that comes more to policy and people.
Interesting. So, Mike, how do we deploy this kind of cool and interesting and progressive technology that'll change transportation at a time when state and local budgets are being cut? The federal, we're struggling to keep the federal government even operating, let alone funding a system, and we seem to have moved from a 6-year system to a 2-year system. So how do we do this, and is it possible?
Yeah, that's a very good question, because it's difficult to maintain what we have in place, as we know in Texas with the funding requirement. I think it's still a moving target. We talk about relationships, and perhaps if the market drives and embraces some of the technology, you begin to see that make things happen, and that's what we see today, particularly when you think about the navigation systems, the in-vehicle systems. More and more people are acquiring those. It's more and more standard in the vehicles. The way that started, of course, was going back and looking at when GM embraced the idea of putting electrical harnesses for all of that technology in the vehicle first, at their, part of the cost of the base vehicle, and then later they could add various technologies if they so wanted, aftermarket. And then they started slowly introducing technology into the vehicles and then the market. We almost created a market to a large extent, but it showed that there was value and utility there. I think it's almost that approach that we have to think about going forward, because there's no clear signal. We're trying, as you know, some of the experiments in various cities on the connected vehicles. That's an enormously important program, even with the autonomous vehicle. It's still something we need to explore and to work toward. But the amount of funding that's allocated to programs like that since ITS was created or introduced in the federal legislation, 92, has just been very poor, just very little technology. Finally got it mainstream where you could use programmatic funds in other areas to invest in ITS. But still there's some opposition in the traditional sectors in transportation about diverting funds from either the maintenance program or from new construction into ITS. But it's slowly happening, and we're beginning to get enough of the technology embedded into the network to begin to see benefits from it. But it takes a long time. I mean, the low-hanging fruit of technology is, in some cases, like in Brian's talking about his case for commercial vehicles, there are other cases where the programs have been underway for 20-some years. And that was the low-hanging fruit. So it just it's difficult. And then as we move forward, technology changes.
So let me ask you then, and let me ask the rest of the panel. I mean, should we be waiting for government funding for the deployment of these new and innovative technologies, or should we be moving ahead based on different business cases that make sense and providing users with the systems that they need and that they're demanding?
Clearly, Google is a good case in point in that. Now, if we all had, Google's got more money than most any government. So if we had that, and I applaud the fact that they're exploring that. That's wonderful. They've already done more for the ITS arena than many others during this period of time, and I applaud that.
You know, I think it's hard to put the government in a position where they have to be the bottleneck, especially when you've got private enterprise that's is so vibrant, coming up with these new innovations, that it really begs the question of the government reevaluating its role in terms of how its position, in terms of how it, whether or not it's in charge of deploying new technologies or trying to make policies to deal with technologies as they're evolving.
Well, I'm going to step up to the podium so I can actually see the audience. This is a chance now, if you've got questions, to go ahead and come up to the mic, and we'll try to handle as many questions as we can over the next 20 minutes. If not, I've got plenty of other questions for the panel because they're really smart and they've got some interesting ideas. Please.
The first question that I wanted to ask was about the shift in legal liability from a driverless car where you have an operator that's primarily responsible to equipment that's responsible. But a second question came to mind before that. Have you tested this on a mountain road in Colorado that's winding around the mountain with a sheer drop-off on one end of it and sat in the car while it's driving it?
So we haven't done Pikes Peak yet, but I'll add that to the list of places we need to go next. There's many roads in California that are like that, and our technology is mainly being tested in urban environments and on highways, so unfortunately we don't get a chance to drive much. And plus, I think that those are the roads that you do want to drive on manually, and we support you continuing to do so. And so on your liability question there, we see that the liability system is actually already working. If manufacturers put out defective products, there's a procedure that ITSA has they can use to force a recall, and they have to be fixed, and there's investigations that go in. So that process is very well worked out. I agree with you, it's a little bit different when the process encompasses a larger problem, which is the car did something they wasn't supposed to do. If the car does something it wasn't supposed to do, then we see that as a defect. So I guess it would fall into that, and we'll stand behind our software and fix what's incorrect about it if there is something like that. So that's our position on that. I think the manufacturers probably have the same thing too.
Great.
By the way, it only took about 5 seconds before the product trial attorney got up and asked us a question. So I don't want him to shoot me. So. Let me go back to one of your questions that you asked the whole panel, and that is about barriers, because all four of you are in a position where you're seeing your products and services and your technology have a true end use, literally immediately. But you're also watching what's happening in other parts of the world. So you're seeing what's happening in China and Europe and places where this adoption is literally off the charts. Go back to the part about the procurement and other things. I'd like all four of y'all to talk more about public-private partnerships, because otherwise, unless there's some way to monetize the technology deployment, I'm not sure how quick this is going to get into our systems compared to what other locations are.
That's a great question.
Yeah.
Okay, Anthony, if you want to start.
Yeah, so I heard actually earlier here, always talking about like government as like bottleneck or obstacle, and we really don't see it that way, right? So we see it as actually a tremendous opportunity of leveraging everything that's out there. I mean, come on, we have the world's greatest highway system. Our transportation system, while it's needs more resource and everything, is actually a huge asset that we need to leverage existing. And so we want to reach out to state and federal governments to see how we can do more and work together in a cooperative agreement. So we don't see it as bottleneck or obstacle in any way, and we want to encourage information exchange, because we might have ways of solving existing problems easier in terms of reporting where the potholes are or measuring the bridge clearances. These are small things, but these are areas where we might have a natural fit together. So we're really open to that.
I can. Oh, sure.
Yeah, I think that's an enormous area of potential. And we've already had a great experience as public-private partnerships. And some of the technologies that are emerging lend themselves very nicely to looking at opportunities. And I'll just mention one. All of these technologies generate an enormous amount of data and information. And if you think about the knowledge pyramid where you have information on the bottom, next is data, next is knowledge, and then comes wisdom, which is the benefit that we're all seeking. That's an area where I think we can have a public-private partnership. I believe, quite frankly, that data will be an enormous asset, is an enormous asset, and will have value. What are the business models for that? I think we're still emerging in that area with respect to the type of data and so forth. I'm not sure that government can manage the data systems, or we can get a third party. And I think what's emerging is third party, meaning maintaining the data systems and doing it in such a way that government doesn't necessarily have to subsidize it, but they acquire and purchase some of the data and information. And same with other private sector entities that are happening now with the trucking industry. So that's one example where I think the public-private partnership will be an enormous asset in managing the data and information that now we're able to collect and generate and has value in several different markets.
So, Mike, you're talking about big data and data analytics to optimize different transportation systems, which we really haven't gone to yet. But we see other industries doing that quite well, and you've got a number of companies that are positioned to do that. All the companies with the Smarter Planet, Next City, all of those companies. It's really where they're moving.
ACS and others that are doing the same thing.
Exactly. Brian, I think you wanted to.
Yeah, I was going to say that we operate with public-private partnerships. That's our business model. We have two stakeholders for Drivewyze Pre-Clear, for instance, law enforcement agencies that man weigh stations and inspection sites. We provide the Drivewyze service to those agencies for free at no cost. To the customers that are the motor carriers, the trucking companies, it's a very old-fashioned ROI benefit of saving time and fuel and money. For the toll road agencies, it's the same model. The Drivewyze service is provided free at no charge to toll road agencies. In fact, I think we're just finalizing testing here with TxDOT for the 5 toll agencies in the surrounding area, and which means Drivewyze will be available to the public very soon here in Texas and around Austin. You'll be able to download it onto your smartphone, and that's offered as a public-private partnership at no cost to the agencies. And for consumers, it's offered at a cost to provide that benefit of not having to wait in lineups or to pay violations.
Great. Wes, did you want to add something?
Yeah. For a startup company, it's when you're dealing with the federal government, we have to be very opportunistic about what we go after, because we can burn through all of our cash just in committee meetings. So we have focused. One of the major problems in the bus transit sector is because the federal government will only fund 12-year buses. You don't have a lot of innovation occurring in transit buses because, in Europe, for instance, the average life of a bus is 6 years, and then there's a robust secondary market where those transit agencies sell those buses into the market. We don't have that here in the U.S. Having said that, our first 2 projects have been funded by the Federal Transit Administration through a Tigger Award and a Clean Fuels Award in Monterey. And so what we're doing is we're focusing on a few very progressive transit agencies that have either discretionary funds that are within their regular budget or funds that they can get fairly easy access to. And our view is that once we get that in place within a large transit agency, and we can show the numbers and the data that show all of these savings that can occur when you move from liquid fuel to electricity, we'll have a lot more interest, and then the transit agencies will be doing a lot of the upfront work that we couldn't do as a startup.
Great. I think I had a question over here.
Tom Clemens of Bentley Systems. A related and I think very complementary technology to ITS is the challenge to move to intelligent 3D models. DOTs all across the United States are struggling with moving from the 2D plan construction world to 3D. By the way, Texas was the first in 1977 to implement CAD. And so my question, and some of the same obstacles, if you will, procurement, legal issues, the contractors have sort of led the world as they've moved to GPS and laser-guided equipment. But my question is, fast forward 3 or 4 years, and Texas DOT has all its assets represented with 3D models. They're planning, they're designing, they're constructing, operating, maintaining in 3D. How would that expedite and help with your technologies moving forward, whether it's wireless or whether it's Wes is dealing with subsurface utilities as you do your trenching to implement your pads? If you could comment on that.
It would, if that 3D data included geolocation information, especially on the Z-axis, that'd be fantastic. It would. We still have to go out and, much like the Google car, there's a Drivewyze car, but it's not on. But it's got to go out and collect data from the roadways and to validate the information that's out there. And so if you had, with that 3D data, it was validated information. It was, there's a lot of value in that in terms of being able to deliver these services. Yeah.
Mike?
Yeah.
Yeah, that's a good point. I think that, for example, Navtech and Nokia, all the mapping people would love to have that information about the highway environment embedded in the navigation system in the vehicle, so you know in advance what sort of terrain or what the geometric alignment might be. You'd also know other information about it. So whether it's, and there's some complicated locations where 3D would be an asset. So yeah, I think Navtech's, their goal was to have all the highway designs in the map. So the headlights begin to cast in the direction where you should go, like the old Tucker or whatever, except you don't have to touch the steering wheel. It's all done with the map system. So yeah, I think there are opportunities there that haven't been touched yet.
Anthony, your whole model is based on 3D mapping, right?
Yeah, so one of the prerequisites before the car can drive is building a really high accurate 3D model of the world, which the cars do on the fly just by driving around. So we're kind of taking after the work that Navtech and others have done, and your company as well, and take that to the next level where we're actually using that in real time to help drive the car going forward. So 3D is definitely the way to go. I can't imagine going back to 2D or paper. So let's go forward.
Oh, go ahead, Wes.
That's a fascinating question. It made me think of something slightly different, which is, I don't know if this would necessarily be a 3D model, but the ultimate model is to convert all of the transportation corridors into power corridors, essentially. So imagine instead of, because this power can flow both ways. It can actually flow from vehicle back to grid as well as from grid to vehicle. So the idea would be that during peak hours when everyone wants their AC on, you could actually pull power off of 300,000 vehicles in any given metropolitan area to peak shave, so that you could balance out a grid. That's assuming you'd have a smart grid, not the kind of grids that we currently operate. But if you kind of see the network, if you see transportation as almost like a packet switch network where each vehicle is a packet, currently the internet runs on this power source, which comes from, everybody just kind of takes it for granted that it just comes from nowhere. Where it generally comes from coal-fired power plants and natural gas power plants, but that energy feeds into the network and it transports all these packets throughout the network almost invisibly. It's almost like a layer below the communications layer. And I think there's a similar analogy to what ultimately wireless power could do for transit, where you have this ability to power all of these packets that are moving around this network, so that each packet is not having to carry its own energy as it transfers around. I could see pretty sophisticated modeling getting involved in that once you go beyond 2 or 3 bus systems and you want to put in 600 buses in a typical transit scenario.
I think I saw a question over here. Yeah, please.
Hi, You all have obviously put in a lot of time and effort to develop these technologies, and I was just wondering about if the U.S. patent system has sort of had your back on this, especially in enforcement areas. Are you worried about any of these technologies being stolen by countries like China?
That's a great question. I'll start a little bit. Interestingly, ITS America did a market data study a couple of years ago, and we found that even at the downturn of the economy, that ITS patents being filed for ITS applications were 17% higher than other technology applications in the same category. So there's an awful lot of activity going on. I do think that a lot of companies in the United States that are members of ITS America have had issues with other countries where they've had their technology taken and replicated, and so I think what you're seeing is you're seeing some companies that are less willing to go into these emerging markets, which seem like huge opportunities, but if you lose your technology, then it doesn't quite work. And so there's a real challenge, and it's something that the administration has been trying to wrestle with some of those emerging economies. I don't know if anybody wants to actually talk about it from their own perspective.
That's a timely question. There was I was watching CNN this morning, and there was breaking news that they had located the shock of all shocks. The Chinese military has a program in place to systematically engage in industrial espionage. That's been, of course, known for a long time, but they actually had a picture of the building that it's occurring from in China. What we're finding, though, is that, and it's probably more, the kind of model that Google has built an empire on, which is that intellectual property is important, but it's really the solution, the overall solution, and being able to effectively provide a solution at a cost that's meaningful to the market. And our view is that IP will always play an important role in these electromagnetic systems that we're creating. But if you think of a company like Siemens and a company like GE, they both have incredible IP portfolios, but it's not really their IP that people buy. It's the solution that they buy, and it's the solution that they buy at a certain cost. And although they both need that IP in order to be where they are, that's not really what you're buying when you buy a solution from those companies. You're really buying the solution, which is a lot of know-how, and it's service level agreements, and it's all of the things that kind of are wrapped around IP, which isn't a Siemens train or a Siemens motor and a GE motor or drivetrain. They're probably sixes, and the bigger issue is are you getting value for what you're paying for?
Does anybody else want to?
Well, I'll agree with Wes, but in our case, IP protection, our IP strategy is a core part of our business plan, and it plays a role here in developed countries. Of course, it doesn't stop other folks from trying to copy what you're doing. It just means there's more protection. But I would say it's a big consideration when you're going into countries that are known to be lax on IP enforcement, and so it's a little bit of a barrier, and you've got to have that trade-off between the comfort of protection versus wanting to exploit that market.
Anthony?
Yeah. So to your hacking question, Google's under attack every day by many different, from teenagers to foreign governments, and it's really important to see where is your technology coming from in your car? Do you want the car being the technology in there because it's exposed to the real world? Do you want it to be by a company that has kind of proven itself to be able to be robust from having external tampering, or do you want it coming from somebody that's doing this for the first time? We think that what we're building is software, so it's actually really tricky to figure out how it works from the end of it. It's not like you can take apart a typewriter to see how everything works, which is kind of the original idea for patents, is disclosing how it works so that innovation can happen faster. And what we really want to see is the technology being deployed to the consumers, to the users, as fast as possible, because that's actually where you're developing the benefits in society for everybody to use. And related to that, we think it's better to have a strong ecosystem than to have one small or one big monolithic solution for everything. So we actually encourage collaboration in that. But IP is obviously very important as well.
We've got time for one last question. I see, okay.
I was just curious how the Google car would perform going through a construction zone where, you got temporary paving and stuff like that changing every day and those kind of things. If you took your Google car out on the Manor Expressway that's under construction right now, how would it perform?
So, we're taking it on 35, which I don't think is the area near the airport that's under construction. Actually, today I think it's going to do a switchover or something like that. But the car effectively knows what the world should look like, and when the world looks differently, it behaves according to what's currently available now. So if you have different paving, that's happening all the time. We can detect traffic cones. We can detect, little orange signs on the side that says, construction ahead. Maybe we'll take that exits. Maybe we'll, ask the user to re-engage depending on what it's doing. We're also very mindful of having construction or law enforcement vehicles on the side of the road. We can detect those ahead of time, and if we can, we'll move over. But dealing with construction zones is one of the most technologically difficult problems to solve, and then also to prove that you've solved it correctly. Because just because you've done 50 or 100 different construction zones and you know how to handle these types of situations, people in the field will always come up with something new and creative for marking their zones and flares and things like this. So that's a great question. Thank you.
Go ahead. I want to ask Anthony a question.
you can ask. Yeah.
Do you anticipate using other vehicles to give the vehicle behind it advance notice of, for instance, construction zones?
Yeah, absolutely, we do that. So we're constantly tracking all the other cars around us because we need to know how we're driving. And so if all of a sudden we see 3, 4 cars in front of us are all kind of peeling over, we'll start to slow down because we might say, hey, maybe there's a stalled vehicle or there's construction or something going on, why everybody's moving to a lane to the side.
I was actually thinking more in terms of what if you have a Google car in front of you that communicates back saying,
sure.
this is what the road looks like right now.
Yeah, so think of it as like all the processing is done locally in the car because we can't rely on the cell phone connection to make sure it's always there. And so what we have is a database of what the world should look like, and that database is constantly being updated. So even though you've never driven in San Antonio because you live in Austin, but your family's there and they have one of these vehicles too, their data is automatically being synced into your car. So the first time you show up there, you have all of that knowledge that they've acquired over time in your car.
So the model is that it gets smart. Your safety increases the more you have.
The more places you can drive, right? The safety is increased by improving the software capability, but the maps has grown kind of by each individual vehicle that's then collected and shared amongst everybody.
All right, guys, I got to shut you down.
All right,
I'm getting the hook. So we're around for the break. I know we're going into a break right now, so I think we're all here. If you've got additional questions or want to continue the conversation, please come up and talk to us. Join me in thanking the panel. I thought this was a great panel.